We are live. Hi everyone, welcome back to Codera. Today we'll be discussing the problem of the day, or you can say daily LeetCode challenge for 8th of December. That is binary tree tilt. So just give me a +1 in the chat if I am audible to everyone and my screen is also visible, so that we can begin ahead with today's problem of the day. All those who have joined, they can just give a +1 in the chat so that we can begin ahead. And apart from this, I just want to know how many people have solved this problem today. You can just comment down your approach or things like that. Hi Kapoor. So today we'll be discussing this problem, that is binary tree tilt. What does this problem say? So this problem says that you have been given the root of the binary tree, and you have to return the sum of every tree node's tilt, right? So this statement, the single statement itself is a little bit confusing, but it says that the tilt of a tree is the absolute difference between the sum of the all the left subtree nodes values and all the right subtree values. So if a node does not have a left child, then the sum of the left subtree is 0, and if it does not have a right child, then the sum of that right subtree is also 0, right? So this is what has been given. Let me draw this case, right? Let's say that you have been given this case, that is 1 is connected to 2 and 2 is connected to 3, right? In this case, what will happen? You have to find the total tilt, right? In this function, in the end, what they will ask you to do is they will ask you to find the total tilt, the sum of the every tree's tilt, right? What does this mean? So if you know about weighing machine, right, there is one weight here and one weight is here, right? And you have this, like, you weight whatever is heavier, whichever part is heavier. If both are equal weights, then it remains constant. Otherwise, whichever side is heavier, the weighing scale tilts on that side, right? So this is very similar to that part. What you have to do is, let's say you come to this node, right? First of all, you see this node. So for this node, just let me know, does this have a right child and a left child? No, it does not have a right child or a left child, right? So that is why it does not have any weights on right and left. So that is why what will happen for this node, for this particular node, it will be 0. For this particular node, the tilt is 0, right? For this node, let us talk about this node. So for this particular node, does it have a left child? No, it does not have. Does it have a right child? No, it doesn't have. So that means that the tilt for this one is also 0, right? Because no left child, no right child, so the total tilt will be considered as 0. Now let's talk about this node, right? For this node, you can see that there is a left child, there is a right child as well. So what is the weight of the left child? The weight of the left child comes out to be 2, and the weight of the right child comes out to be 3. So you can see what is the absolute difference between them. The absolute difference is 1. So it will be tilting towards this side, but that doesn't matter. You have to calculate absolute of 3 minus 2. That gives us 1, right? So if you will draw the tilted tilt binary tree, so it will give me 1, because for this root, the root of the tree, that is 1, the tilt is 1 because it has child, total sum of left child as 2 and total sum of right child as 3. After this, for its left child, the sum is the answer will be 0. For its right child, the answer is 0. So the total tilt for this problem, for this test case, is 0, right? Is this much part clear to everyone? Just quickly write +1 in the chat if this part is clear to everyone, so that I can move to the next test cases. So let's say I have this test case where I have 4, 2, 9. Let me write it, where I am having, first of all, I'm having 4, then 4 is connected to 2, 2 is connected to 9, and after that 4, 2, 9, I have 3, 5 and 7, right? I have now 3, I have 5 and I have 7 here on this side, right? 4, 2, 9 and 3, 5 and 7, right? So this is the case. Like, for this case, what we can do is, you can see for this case that what will happen. First of all, you will try to calculate for the roots, right? From the bottom up. Why? Because first of all, let us see how we should do it. After that, we can talk about the code part and which particular traversal we should use. That part will be done. You can see for this case, right, for this 3, you can easily say that for this 3, it doesn't have any left child or right child, so the tilt for this is 0, right? The tilt for this case is nothing but 0, right? This is very much clear. The tilt for this 5 is also 0, and the tilt for this 7 is also 0, because it does not have any left child or a right child. But now let us talk about this 2. For this 2, can I say that the total tilt for this 2 is on the left side is 3, and total tilt for this 2 on the right child, on the right side, on the right subtree is 5. So the total difference in the tilt is absolute of 5 minus 3, that gives us 2, right? So for this note, the tilt is 2. For this, can I say that the left child, since it doesn't exist, so I have to think of it as 0, and for the right child, the child is 7, so that means that the total value will be absolute of 7 minus 0, that gives us what? 7. Now let us talk about this case. So for this 7, what will happen? For this 4, what will happen? Will you say that you will be finding it like this, 2 minus 7, that will give us a 5? You will say that it will be 5, but let us see, that is that the case? No, that is not the case. It is coming out to be 6. How that comes out to be different? Because for this case, what will happen? Let me first of all draw the tree in this manner. This will be our tree. Let's say this will be the tilt diagram for it, not the tree actually. This is what? This is 0. This is 0. This is 0, because leaves will always be 0. After that, this comes out to be 2. This comes out to be 7. Now you have to find for the root. So let me just make some space, and let's now try to understand for the root, how will I calculate the tilt? So again, as I told you, hi Akshay. So again, as I told you, that what you can do is you will have a weight on the left and you will have a weight on the right. Perfect. So for this, what is the total weight on the left? Can I say that this is the total weight of the left? Yeah, right. So this is what? 2 plus 3 plus 5, right? What does this mean? This means that the weight of the left child is equal to what? The weight of the left child is equal to weight of the left side is what? If you, this is the current node, then its weight is what? Current value plus the left child plus right child, right? This is what it is. So what will be the answer? 2 plus 3 plus 5, and this gives us what? 10, right? So for this, can I say that the weight is 10? Yes, I can say that. For the right part, what should I say for the right part? For the right part, I can see that I have 9 and I have 7. What is the total weight? 9 plus 7 gives me a 16. So the total weight on the right side is 16. Now I have to calculate the difference. I do not have to consider tilt. Tilt is for the node, but I have to calculate tilt is for a particular node, and for that particular node, it is the weight is it is the difference of absolute difference of the total weight on the left side and the right child, on the left left subtree and the right subtree, right? So that is why, since this is 0, so since this is 10 and this is 16, so absolute of 16 minus 10 gives us 6, right? So for this case, you will say that the tilt is 6, right? So for this, the tilt is 6. We can see 6, 2, 7 and triple zeros. So this is how the tree also looks like, that they have shown the tilt part: 6, 2, 7, 0, 0 and 0, right? But is that the answer? No, you don't have to return the tree. What you have to do is you have to find the sum of all the tilts. So that is 6 plus 0, 6 plus 2 plus 7 plus 0 plus 0 plus 0, which will ultimately give us 8 plus 7, that is 15, right? So the total tilt for this case is 15. Is this much part clear to everyone? Just quickly let me know in the chat if this part is clear to everyone. Only then I can consider moving ahead. Is this part clear to everyone? Is this part clear to everyone? Please write a +1 in the chat if this part is clear to everyone, so that I can think of moving ahead with this problem and we can discuss upon it further. You can consider giving a +1 in the chat quite quickly so that we can begin ahead. Okay, right. Let's move ahead. Perfect. Let's move ahead and see what will happen. Let's say that I draw the cases again and you have to tell me, right? Let's say I have a simple tree, that is let's take that tree only that we had just discussed now. Okay, right. So let's make some space for this tree and let me draw it once again first of all. So let's say that the tree is again 4, then 2, just making some space, 4, 2, then 4, 2 and 9, and then I think this was 3, this was 5, and this was 7, right? Let me cross check. 4, 2 and 9, and 3, 5 and 7, right? So for this case, what you could do is, you can easily say that for this case, what will you do? You will always have to find the tilt. So what is the value of tilt? The tilt will be nothing but tilt is equal to absolute of left left subtree minus the right subtree. This is perfect. But the thing is that you will always have to accumulate the tilt, right? So tilt is equal to tilt plus absolute. Since you have to print the total tilt, so that is why the total tilt will come out when you will take the sum of all the tilts, and for that you can use a resultant variable, that is result is equal to result plus this. So you can, in this result value, you can store all the tilts, right? After this, one more thing that you need to notice is that you have this left and you have this right. Perfect. But how do you calculate this? Let's say for this case, when I'm standing at this 4, once I'm standing at this 4, so what should my left and right return such that I am able to get that? Suppose that I am standing at this position, right, at this 4. So for this, what should be the answer? So if I am at the left, first of all I'll move to the left child, and the left child will be what? The left child will give me the left value plus the left child for it. Suppose this is my current node, then this will give me the left child. First of all, it will give me the for the current node, suppose this is 2 is my current node, so current value plus left child for this, that is 3, plus the right child. So this gives us 2 plus 3 plus 5, which is nothing but 10, right? So this is, in this way you can get the left part completely, and for getting the right part you can do the same thing, current value plus the left value plus the right value for this particular subtree. If this was larger, even in that case this would have worked, because since you are writing it using a depth first search approach, not a breadth first search approach, right? So for this the answer will be 16, and then you can easily calculate it as absolute of the left subtree sum minus the right subtree sum. So 10 minus 16 will give us 6, right? So I hope that this much part is clear to everyone. Now the question comes that how actually we are going to implement this. So as I said, that you can take a resultant variable that will be storing the sum of all the tilts that are present in the tree. Apart from this, what you need to notice, one thing is that for doing this part you will be using, first of all, what do you want? You want to find the left child, then you want to find the right child, and after that, first of all you need to do that, and then for this part you want the root as well, right? So that is why, since you can see that what we are doing basically is, let me show you the traversal part. For this part I come to here, I come to this 3 and I check for its left and right. So I can see that there is nothing, no left or right child. So that is why this 3, for this 3 the tilt is 0. After that, what will I do? I move to this 2, but I haven't touched this 2. I just move up and I go to this 5, that is the right child, and I see that for this right child the tilt is 0 again, because it has no right or left child. Now since I have traversed up till here, since I have traversed up till this 5, so since I am moving up, again. So moving up, I see that now what will be my tilt? So now my tilt is nothing but my right child plus my left child. That is it, right? My right child minus my absolute difference of right and left. So that gives me absolute of 3 minus 5, which is nothing but 2, which is also the value of this node. That doesn't matter really. After that, what will I do in this case? Will this 2 is perfect, this 2 is my tilt, right? But what is the value that I need to give from this node? From this node I need to return the value as well. This node returns me a 3, this node returns me a 5. So should I return the 2 from here? No, I shouldn't. What should I do for this is, the value that I should be returning from this left subtree is nothing but 2 plus 3 plus 2, that is current node value plus the left child value plus the right child value, which will give us 3 to 6 plus 1, that is 8, right? This is what it will give us. Not 8, actually this was not 5, this was this was not 3, this was 3, but that was 5, right? So this was 3, so 2 plus 3 plus 5, that gives us 10, right? So in this way you get the left child. So what you have to do basically is, let me show you the code part, like how we'll actually be implementing this question. So what we need to do is, first of all, we'll be having this function that is find tilt, and in this you will be given the root of the tree. After that we'll be running a simple DFS function. In the DFS function, since what we were doing in this part is, we were first moving to the left child, then we wanted to move to the right child, and then we wanted to calculate the tilt for that particular root, right? After doing that, we went to the root. After calculating the tilt from the root, we want to return the sum of the left child plus the right child plus the root value, right? This is what we want to return. Suppose I have to return this complete part, right? For this 4, this is the complete left subtree, so that is nothing but 2 plus 3 plus 5, which is 10. Similarly, for this case, I have to return this. You can assume this to be 0, so this will be nothing but 9. What will happen in this case is, I'll tell you what will happen in this case is, you move here, you see that there is no left child, so after that you move towards the right child, you see the right child, you mark its tilt as 0. After that, the tilt for this 9 is nothing but 7, because there is no left child, so that will be 0. After that, once that much part is done, so you can simply see that this 9, what will I do with this? Now I have the tilt as 7, that is perfect, but now I want to have this complete left child, right? Right subtree. So that is why I will have to do 9 plus 7 plus 0. Why? That is the current node value plus the right child plus the left child. So I can do this using a post order traversal, right? For doing this, I can use a post order traversal. That is, first of all, I can go to left child, then I can go to the right child, then add the once I come to the root, so I can calculate the tilt for that particular root. I can keep on adding that particular tilt, all the particular tilts for the current nodes. Then after that, once I am at the current root, so I'll add its value as well. I'll add these 3 values, and then I'll return it to the parent of this current node, right? This is what I will do. Now again, let me show you the code part. So what I have done is, I have calculated, if I first of all, I'll be checking if the root is null, if the current root node that I am at, if it is null, so I'll simply return a 0. After that, I will mark my left is what? My left will be DFS of end left, that is, I'll be calculating the left subtree. So for calculating the left subtree, I'll be calling this function, that is DFS function, for the left part. That is how you do a pre or post order traversal. That is, first of all left, then root, and then right. Okay, so you can, then after that, what you do is, you calculate the right subtree as well for that particular node using this function, that is DFS of n right and left. Notice that this DFS function is ultimately returning the left subtree or the right subtree, that is current node value plus the left child plus the right child. Okay, after that, before doing that, you also need to, I'll add the this tilt. Current tilt will be what? Absolute of left minus right, and since you want the total tilt, so you will keep on adding it, accumulating the answer in your resultant variable. And once that part is done, so you can once the DFS is over, you will return back to this function, and you can simply return the resultant total tilt, right? So is this much part clear to everyone? Just quickly let me know in the chat if this much part is clear to everyone. If there is any doubt, though, feel free to ask, but if there is any doubt, you can mention that. Otherwise, I'll be telling you the time complexity for this code. So for doing this, the time complexity for this code, first of all, talking about the technique, so for finding the tilt, I did what? I did nothing but absolute of total left subtree minus the total right subtree, right? This is what I did for the absolute part, for finding the tilt. After that, I also had to accumulate, so that is why I kept on adding this tilt in my resultant, that is result plus is equal to absolute of left minus right. for a particular current node, and in this way it will give me, if once I will iterate for all the nodes, so I'll get the total tilt for the given binary tree. After that, since I have to return for that this particular current node, I have to return, let's say it has a lot of nodes, so this tilt is calculated for this particular node, this particular node, this particular node separately. For this node, let's suppose that this much part is there, so I have to return since this is the node. So for this node I have to do what, this is the current value, let's say it is current value 10, then its left child is current value 20, and the right child is current value 30. So that means that total this is 60. So that is why in the end, for this DFS function, from a particular DFS function, I am returning the complete, that is total sum of the subtree, whether it is left subtree or the right subtree. It can be anyone, right? So I am returning the left child, that is this, and I'm returning the right child, and I'm returning the current node. So this will give me the complete left subtree for this particular node. So left plus right plus you take the current node value, right? So this much part I think must be clear to everyone. Apart from this, one more thing that I wanted to tell you is that since for this function we are using a traversal, post-order traversal, that is left then right and then root. This is what we are doing, and this takes order of n time because we are iterating through each node exactly once. And apart from this, besides this, the space complexity is nothing but order of 1 because I haven't used any extra space. So I will show you the code part again. Basically you just have to run a DFS function, that is post order function. This is the code for the post order function. If the current root is null, then you can simply return 0. Otherwise you will calculate the left sum of the left subtree for the current node and sum of the right subtree, the total right subtree, calculate the right subtree for the current node, and once that is done, so you will calculate the total tilt for this particular node. After that, since you must be having a node above the new, so that is why you will be returning the left plus right child of the current node plus the current node value, right? So this is how we are doing it. In case if anyone has any doubt, so they can mention that in the comments, and I'll be looking into the comments to reply back to your doubt as soon as possible. If anyone had any other approach, so they can mention that in the comments and we can discuss about that as well. Besides this, you can consider subscribing this channel and like the video. We bring LeetCode daily challenges every day. So thanks a lot everyone for watching, and I'll see you soon in the next video.